In this video, I'll be demonstrating dimensional analysis using the more complicated problem that was included in the review packet on dimensional analysis. So, let's take a look at the problem. I've got this up on the board for us to take a look at. And so it says, large bakery receives 2 pallets of flour, each of which holds 10 large bags of flour. Each bag contains 50 pounds of flour, and the density of flour is 0.31 pounds per cup. The baker is planning on making cakes to shipment of flour, and each cake requires 3.5 cups of flour. How many cakes can be made from this flour? So lots of flour flying around there all over the place. But what we want to be thinking about as we get going on this problem is strategy. Planning this type of problem is going to be the key way to solve it. And in this case, we've got a lot to work with, numbers flying all over the place, and we are not explicitly told where we're starting and where we're ending. We need to be able to sort that out from the words. Let's start with where we're ending. What are we trying to get to in this problem? For that, we just need to go and look at the answer, the question is asking us, and we see it says how many cakes. So we are trying to get to cakes. That will be helpful for our strategy, and so we'll show that as our last step. Finding where we start from may be a little bit more difficult. The way we should find this, but by looking for the information that tells us how much do we have. So we're looking through this information here to try to find which thing tells us how much, so a specific quantity that we are given to use, and we find that at the beginning in this case. 2 pallets of flour, which means that in our strategy we should be thinking of starting from pallets. Seems like we're going to have a lot of steps in between here, so we'll need to plan about how we can get through this before we try to set it up, just to make sure that we're organized to get through a difficult problem like this. In the planning stages, we can think about working from either end of this. So we could think about pallets. What can I convert pallets to that will bring me closer to cakes? Or, alternatively, we could start at the end, thinking about cakes. What could I convert to cakes that will bring me closer back to my beginning, where I'm beginning with pallets? We can actually do one, the other, or both in tandem until we get a connecting point in the center. So for the purpose of this demonstration, I'm going to think about starting from both ends, just to show how this would be done. So let's start with the pallet end. What I would be thinking about is what can I convert pallets to, and so we want to look for some information in there that relates that to some other unit of measurement. And I find that soon after the pallet part in the problem, where we say that each of which holds 10 large bags of flour. This tells me that pallets are related to bags, and so that could be one step. I can convert from pallets to bags. I'm going to go to the other side just to show how I could work from the end, and so I'm going to look at cakes. I want something that is related to cakes that could bring me back to something about the pallets. So looking for any information that connects cakes, I see that each cake requires 3.5 cups of flour. So it seems like we could, if we had cups, get to cakes. And so I'll put that in here as one step back from cakes, something that might help us get closer to what we're looking for. So now to complete the analysis here, what I would see from this is that we have other information here, so I just go through and think about the other information provided. Each bag contains 50 pounds, and the density of flour is this 0.31 pounds per cup. These two relationships tell us that we can take bags and convert that to pounds. And then pounds can actually go to connect to the cups. So taking that all the way through to cups. So at this point, we do have a connected strategy with pallets leading all the way through with things we can convert all the way through to cakes, and that's what we're looking for. So at this point, what we need to do is to go back and start setting up the calculations. In order to do so, we're going to have our conversion factors, and so it might be helpful to organize this in the form of equations showing how the different units are related to get started. So we want one equation for pallets and bags. So some number of pallets equals some number of bags. We see that each bag or each pallet holds 10 bags. So we say that this is one pallet equal 10 bags. This is one of those relationships that's not universally true, but does apply to our specific case, So it's usable even though it wouldn't apply to other situations. Working forward, we want something with bags and pounds. So some number of bags equals some number of pounds. Each bag contains 50 pounds of flour, so this is one bag equals 50 pounds. Next one, we're looking for pounds and cups. This one might be a little bit difficult to see, but we have that the density is 0.31 pounds per cup. Or in other words, if we have one cup, that is 0.31 pounds. So again, we can set those equal to each other. 0.31 pounds equals 1 cup. Finally, we're looking for something that connects cups and cakes. And so what we look back for is to find that relationship is that 3.5 cups is used to make a cake. And so 3.5 cups equals 1 cake. We've now got all the relationships we need. And so it just comes down to setting this up using our dimensional analysis. We'll start with the value that we know, the one that's related to our size. And so that'll be our 2 pallets. And we'll put that over 1 just to make it into a fraction so that we can use that. First conversion factor is pallets to bags. So we use the equation that we had up above. We make sure that we have pallets on bottom. So placing our units first. Pallets on bottom, bags on top. This way we can be sure that the units will cancel and plug in the numbers with that appropriately. 10 bags equals 1 pallet. Continuing along the same way, we're going to do our dimensional analysis. So bags go on bottom of our next one, and we're going to be converting to pounds here, so pounds will go on top. Then place the numbers appropriately. We had 50 pounds and 1 bag for that equation. Same thing, continuing along here. We want pounds on the bottom to cancel with the pounds from before. Cups on top. Place numbers appropriately from our equation. 1 with the cup, 0.3 from pounds. Finally, we have our last conversion factor. Again, looking at units first, cups need to go on bottom to cancel with the cups from before, leaving cakes on top, and it is 1 cake for 3.5 cups. At this point, we would go through and solve this to find that, as we see, it comes out to 920 cakes. And so this would just come from doing the math that we have outlined here, plugging that into your calculator, you would be able to solve it that way. And so this will take us through this example. So main steps that we did here, first off, having our planning step was very important. We need to make sure that we were planning what our units would be in sequence and making sure that we have conversion relationships available for that. Next step, we outline the specific relationships that we'd be using. That can be a good thing to keep yourself organized. If you feel very comfortable with it, you could skip that step, streamline the process, and plug in directly when you do the setup for the dimensional analysis. But I generally recommend that you take more steps at the beginning so that you are working through this very cleanly. Finally, we set up our calculation, again making sure our units cancel, so we will show that as we go through here. Pallets cancel with pallets, bags cancel with bags, pounds cancel with pounds, and finally cups cancel with cups, leaving us with only the cake as the remaining unit. And so we end up with an amount of cakes, 920 cakes. That'll take us through the problem, and good luck with working other dimensional analysis problems in the future.